Hello, welcome back to Learn Physics. In today's topic, we are continuing with the force and laws of motion. In last video about that force and laws of motion, I told you the important laws and derivations of this chapter, isn't it? So today I'm going to do the in-text exercise as well as the exercise questions. Okay, so the first one, this is from page number 118 of your textbook. Okay, first question, which of the following has more inertia? First one, a rubber ball and a stone of same size, a bicycle and a train, 5 rupee coin and a 1 rupee coin. Inertia means what? It is the natural tendency of an object to continue in its state of rest or uniform motion. Okay, but inertia is a property of mass. It's a measure of mass. Measure of mass. That is inertia. Inertia is a measure of mass, means as mass increases, inertia also will increase. As mass decreases, inertia also will decrease. That means, say if we have a higher mass, the object will be having the tendency to continue in its state of rest for a long time. Okay, if the mass is less, then the object will be having the tendency to, let's say the inertia also will be less for them. Okay, so here, which of the following has more inertia? A rubber ball and a stone of same size. Okay, rubber ball or stone, which one will be having more mass? Stone will be having more mass, right? So it will be having more inertia. So the first one is stone. Stone has more inertia. Now second one, a bicycle and a train. Tell me, bicycle and train, while we are considering which has more mass? Train has more mass. And see, 5 rupee coin and a 1 rupee coin. Which is the answer? Yes, 5 rupee coin is more mass. Has more mass, isn't it? So the answer is like this. Second one. In the following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player to his team, who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. Also identify the agent supplying the force in each case. Tell me how we can find out what is meant by velocity, in which and all position the velocity of the ball changes. That is it, it's asked. So tell me, before that we should say what is meant by velocity. Velocity equals change in position. Change in position divided by time, or we can write it as displacement divided by time. That is velocity, isn't it? Velocity is displacement divided by time. If the object is displacing, if the object is changing its position with respect to time, that is in direction also we should mention, then only it will become the velocity, isn't it? So where and all the position is changing. A football player kicks a football to another player to his team. So the player is kicking, isn't it? The player is kicking the ball to the another player, to the second player. So I will write it as this is first player and this is second player. When he is kicking the ball to the first player, when he is kicking the ball, there he is changing the velocity. Okay, and then next one. So the first case is first player kicks the ball to the second player. So that kicking moment is changing his velocity. Okay, then who kicks the football towards the goal, and to another player of his team who kicks the football towards the goal. So the second player is kicking the ball to the goal. Isn't it? So again the velocity is changing. He is again giving a velocity. So velocity is again changing over there. And then the goalkeeper of the opposite team collects the football. So there also, yes, now here in what happened then? Goalkeeper. He is collecting the ball. While he is collecting the ball, what will happen? The velocity again becomes 0 over there. Okay. So I am throwing one object with a particular velocity. Another person who is sitting there, he is without catching it, again he is applying a force. Isn't it? So again the velocity is changing over there. So in all these positions, velocity changes means there will be having some force also, because it is, if there is a change in velocity, then only acceleration will be there. If there is acceleration, then only force will be applying over there. Isn't it? So acceleration means change in velocity divided by time. Acceleration is the change in velocity divided by time. So if there is a change in velocity, then only acceleration is existing, right? So acceleration, if acceleration is existing, then only force will be there. F is equal to ma. Okay. So and kicks it towards the player of his own team. Okay. So and then goalkeeper, what he is doing? He is kicking the ball to his own team member. So there also to the another player. In all these positions, velocity is changing. Okay, understood? Now the third one. The same page number only, 118. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Okay, so a tree is there. We are vigorously shaking the branch. What will happen? Some of the leaves will get fall down. What will be the reason for that one? Because the tree was at rest. So all the leaves are having the tendency to be at rest position. So suddenly while we are shaking the branch means what will happen? Some will be having the tendency to continue in its state of rest. Okay, so some will be in the rest position itself, not shaking, but the whole other tree is shaking. That is the reason it is getting detached. So that means it is due to inertia. Some are having the tendency to continue in its rest position. What is the meaning of that? It has inertia. Because of inertia only it is getting detached, because it is having the tendency to continue in its state of rest, but the others are having the tendency to continue in its motion because they started moving, isn't it? So that is the reason. So that also because of inertia. Next is fourth one. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backward when it accelerates from rest? What is the reason? So while we are at rest position, the bus was moving. When the bus was moving, suddenly it is coming to rest position, isn't it? Moving bus come to rest position. What will happen? It will be the forward. The passengers will be moving forward. Passengers will move to the forward direction. What is the reason? Because the passengers all were moving first, isn't it? While they are moving, they have the tendency to continue in its motion. The passengers will move in the forward direction. What is the reason? Initially the bus was moving, so the passengers also in the motion. Passengers also were at motion, isn't it? Suddenly the bus came to rest. Bus at rest. Bus came to the rest position. Then also passengers will be having the tendency to continue in its forward motion, isn't it? So it was having the tendency to continue in its forward motion. So their legs and all will come to the rest position. Their legs and all will come to the rest position, but their body, the upper part of the body is not ready to come to the rest position. It want to continue in the state of motion. Okay, so it has come to the so it is moving forward. And in the next case, it is when we are starting the bus, what will happen? You only imagine, see, while we are starting the bus, the whole body was at rest, isn't it? So suddenly when we are starting the bus, the lower part of the body will be ready to continue in the state of rest position along with the bus, isn't it? But the whole body was at rest and the lower part of the body will be ready to continue its motion along with the bus. But the upper part of the body will be still having the tendency to continue in that rest position. So that is the reason they are moving backwards when we are starting a bus which was at rest. Okay, clear? Next is in page number 126. In page number 126, first question. If action is always equal to the reaction, explain how a hose can pull a cart. If action is equal to reaction, how a hose can pull a cart? Okay, so see, hose will be giving a downward force, isn't it, to the ground. The ground will give a reactional force, okay, equal and opposite forces, then how the hose can pull a cart. Okay, so if it is giving an equal and opposite reaction, and the opposite reaction is used to overcome from the reaction, it is used to overcome the force due to friction. Okay, so it is reducing a frictional force. When it is overcoming the frictional force, the object can move forward. So the reactional forces together is acting on the hose and the cart, not only to the hose and the cart, and when it is overcoming the frictional force, the hose can move forward. Okay, so actually because of this force we should divide it into components and all, that and all you will be learning in the higher classes. Now it's not required for you. This action is there, reaction is there. If the reaction is acting on the hose and the cart system, and if it is able to overcome the frictional force, it can move forward. Okay, explain why is it difficult for a fireman to hold a hose which ejects large amount of water at high velocity. Yes, a large amount of force will be acting with a high velocity to the hose, isn't it? Because fireman, its water will be coming with a very high speed, isn't it? At that time a reactional force will be acting on the fireman. Okay, because of that reason only it will be because of the reactional force of the hose, it will be difficult for the fireman to hold the hose. Okay, so then third one is a numerical. From a rifle of mass 4 kg, a bullet of mass 5 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. So here I am considering the rifle and the bullet separately. Okay, while we are taking a rifle which is having mass of rifle is 4 kg and mass of bullet is 50 gram. So this is in kilogram and this is in gram. So we can first itself convert to kilogram. Kilogram to kilogram conversion divided by 1000. So it is 0.05 kilogram. Okay, and fired with an initial velocity of 35 meter per second. So it is moving with the velocity of. So initially both were at rest. Okay, then afterwards the bullet was starting moving with the velocity of 35 meter per second. So velocity of the bullet equals 35 meter per second. Okay, here it is initial, we should find out the recoil velocity of the rifle. Okay, this one we can find out. How we can find out? Using conservation of momentum. Momentum before collision will be equal to momentum after collision, isn't it? So here we are going to consider using law of conservation of momentum, that is momentum before collision is equal to momentum after collision. Momentum mr plus mb ub equals mr plus mb bb. Now, so what is the initial velocity of the rifle and bullet initially? Initially both were at rest, isn't it? So ub will be equal to 0. So the left hand side fully it will become 0. So while we are writing 0 equals, what is mr? 4 into, what is vr? We don't know, plus mb 0.05 into vb. vb is 35. So we will get VR as, so I am taking this to the left side, 0.05 into 35 divided by 4. Okay, so how we will be getting the answer for this one? Like that we will get. So minus 0.432 meter per second we will get, but the velocity, since we know the bullet is moving forward, rifle will be moving backward. So the backward velocity will be equal to VR equals 0.432 meter per second. Since it is here and all, we considered everything in the same direction, isn't it? But while since it is coming negative, we understood that it is moving, velocity is in the opposite direction. So negative velocity means it is in the opposite direction. We told you it's a vector quantity. When it is a vector quantity, it will be moving in the opposite direction. Okay. So the next one is in page number 127. 127, fourth question. Two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities 2 meter per second and 1 meter per second. They collide, and after collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. So here two objects are given. So first one I am taking it as m1 and second one I am taking it as m2. Okay. First mass is 100 gram and this one is 200 gram. So gram to kilogram we can convert. So 0.1 kilogram and this will be 0.2 kilogram. Dividing it by 1000. Okay. And moving with the velocities 2 meter per second and 1 meter per second. So u1 equals 2 meter per second. u2 equals 1 meter per second. They collide, and after collision the first object moves at a velocity of 1.67 meter per second. So after collision v1, after collision means v, isn't it? That is equal to 1.67 meter per second. What we should find out? Velocity of the second object you should find out. How we can find out the velocity of the second object? m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. Okay, so m1 u1, that is m1 is 0.1 into 2 plus m2 u2 0.2 into 1, that is equal to m1 is 0.1 into 1.67 plus 0.2 into v2. Now we are going to find out the value of v2. Now only calculation is there left out. You can do it, right? Yes, 0.2 plus 0.2, that is equal to 0.167. 1.167 into 1 is 167. One more digit we should shift. So 0.167 plus 0.2 v2. Therefore, V2 equals, how we can find out? This is 0.4 minus 0.167 divided by 0.2. So, you will get it as 0.23 divided by 0.2. You will get in a point. So, 1.16 meter per second. You will get it as 1.16 meter per second. You will get it as 1.16 meter per second. Okay, clear? Understood? So all these are the in-text question answers. Okay, now we will be starting doing the with the exercise questions. Okay, in next video we will be starting a exercise question. Okay, so understood? Clear all of you? So here you should understand some of the formulas and some of the laws, that is first law, second law, third law. Okay, and conservation of momentum. Okay, so the formulas are only two. M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. This is one of the formula, and the other one is F is equal to MA. Okay, Newton, F is equal to force. What is the unit of force? Newton is the unit of force. How we can define Newton? That also there. How we can define Newton? F is equal to MA we know, isn't it? We know F is equal to MA. See, F equals MA. If we need to get, if F is equal to 1 Newton, M is equal to 1 kilogram and acceleration equals 1 meter per second square, then F is equal to 1 Newton. Okay, how we can define Newton? If 1 kilogram if an object having mass 1 kilogram is acting with an acceleration of 1 meter per second square, then the force acting on the object is called as 1 Newton. Okay, so clear how we can define 1 Newton. So these are some of the important questions from this chapter. Laws of motion and inertia, momentum, P equals mv. That formula also very important. P equals mv, F equals ma, and this one m1 u1 plus m2 u2 equals m1 v1 plus m2 v2. All these formulas are important, and inertia related questions and momentum related questions. So slowly only it is coming to rest position, so we won't be getting hurt. Okay, so all those questions in the last video I explained all these momentum questions and all, isn't it? So I hope all of you understood all these things. I'm winding up for today. In next video we will be coming with the many more exercise questions. Okay, if you like the channel, please don't forget to subscribe. Okay, thank you for watching. Bye.